if you ask system design, the first question comes in our mind that what is system design? So here just I found a definition of system design, which says that system design is the process of defining elements of a system like modules, architecture, components, and their interfaces, and data for a system based on specific or specified requirements. So that sometimes this definition, it doesn't give the exact meaning. So I'll try to elaborate that first. So you can see I have mentioned some of the systems. Like in our everyday life, we use so many applications. We use Uber, we use WhatsApp, we watch videos on YouTube, we have Instagram, Google Maps, even many of the food applications like Swiggy, Zomato. Many of these applications are actually running a big system behind it, a big architecture, different components that are working behind it. So this is actually means being a user, we don't know. We just see that okay, we send a message on WhatsApp and someone else receive it. We book a cab and we see okay, cab is coming, where exactly it is, and then how soon it will reach to your location. And when you are in cab, you know how much time you it will take to take you to the destination. Even you watching YouTube videos or maybe Instagram, so the feed is continuously showing on Instagram that what next you can watch, what is there popular, what is other person is putting new videos, your friend or you, the person to whom you follow. So these things are there, but we never thought that okay, how exactly does these things work? We just trying to be a user of these all applications, but there are a lot of things running behind it. And I mentioned on the right hand side components plus design consideration. So there are some design consideration need to know when we are developing these kind of systems. See, these are very big systems like Uber, WhatsApps are uh, millions of users are using this, millions or billions of users are using it, and handling such kind of users or the data that is generated by user is very critical. So right now, I've just mentioned here few components like scalability. As I mentioned, there are millions of users are using this. So how we can scale our system, how the system will be available every time. You open WhatsApp, it will be available. Like all the message are visible to you, even if you are not online. And if you open Uber app, you know, okay, you immediately get a response that how many cabs available in your area. It asks for a destination and then accordingly you book. Then reliable in the sense on WhatsApp, if you're messaging anything on YouTube, you're uploading your own video, that video will be there. Like anytime, every time you go to your own channel, you will see that video. It will not get deleted. It will not be lost in between. So the system is reliable. See, we will get into definition or details of each and every these word. I'm just giving a maybe I can say high level view of these words. Fault tolerance. What if your WhatsApp is not running for whole day? It will be a big loss for WhatsApp. So how they can make their system in a such a way that it is fault tolerance. Anything happen, still it will be giving you all the services that is needed. And the latency and throughput are two different things. Latency is that how soon you get the response when you send a request or when you upload something, how soon you get the message that your video is uploaded. And throughput is like how much data you can transfer from one system to or one machine to another machine over the internet. And there are other components also I mentioned like cache, server, database, DNS, load balancer, or CDN. We'll get into details of these are some of the components, not all, but very few. These are a very small list of components that I mentioned here. It's only because I don't have time, and we will get into every each and every components as we'll proceed ahead. So far, this is what it is. System is something that we develop, whether it is app, whether it is application, whether it's a cloud-based web service, in which you have multiple things running behind, and we are trying to deliver some service or solution to the user. And what are the components behind? So, any question on this? No? Okay. Let's move ahead then. See, I want to start with a very simple example. Simple example in the sense, I don't want to get into all the components, but we will see that when and how, when we will get into any kind of problem, how those components we need over the period of time. So I'm just giving an example to you. For example, see here is a user And this user is like you, me, and anyone will be can be a user. And that user is making use of either web browser or his mobile app. And that user will what he or she will do is just type the website name or just start the app itself. So what they will do, okay, www.myweb.com. Okay. So when see this is a process, you just need to understand it so that you will get to know what exactly so what exactly happening behind the scene. I'm not sure how many of you know, but I'm trying to give you a quick overlook of what exactly happening behind the scene. See, whenever we type www.myweb.com, just a website, I just gave us some name. And when you type that name, what your client, whether it is web browser or mobile app, what it does behind the scene is first, see, for to connecting to any app server or web server behind your architecture is the machine is not identified by the word itself. Every machine or every web server which is running on the cloud has its own IP address. See, on internet, you cannot identify any machine. Like if I want to connect someone, I want to know the IP address, then only I'll be able to connect to that machine. It is not through the text that we give. So what is happening behind the scene is this mobile client or web browser, it will first go to DNS server. DNS stand for I mentioned here, domain name system, where it will go and ask that DNS server is I'm looking for www.myweb.com and could you give me an IP address or that is also a public IP address of the nearest server to me? Because see, if I am doing myweb.com in India, then whichever server that is close to me, that IP address I should get so that the latency will be lesser. Okay. So in that case, DNS will look after okay which server is closer to me and it will return to me the public IP address of that server. And it will return me that IP address to my web browser or my web application, mobile app. Sorry. And then with that IP address, that public IP address, I will send the request to the web server. So you can see the step number one is my app will send www.myweb.com to the DNS system, a DNS server, and DNS will return me public address of that server. See, this step number two is not just one IP address you will get it, but you will get it multiple list of IP address. So that is also one thing that maybe one IP address is not responding to it, so you can make use of another IP address that will be taken care by your web browser or mobile app. If something is not responding, it will switch to another IP address. And these IP address list also not same list like name same sequence of IP address is not given to user. It will be like randomly generated IP address which are not in same sequence will be given to different. Otherwise, every user just imagine if this IP address is stored always first, and that same IP address is given to thousands of users, then this particular server to which this IP address is belong to will get overloaded. Okay, so that's why they provide list of IP address, and that list is not same for all the users. And then user's machine or browser will send that request with using IP address to the web server to which this IP address belongs to. Okay, so in this particular case, just imagine that you initially you have a web server which have everything inside. Like this is a single web server which have database within it, application logic, cache, and many other things which are required for the application or myweb.com to run. All these things are stored in a single web server. Okay. And what the server will do, server will respond, give a response to your client in a different format. Like for example, if you're using a web browser, you will get a response in HTML or JavaScript. And mostly when you're using mobile app, it will be a JSON format. And all the description, like the full form of all the HTTP IP, it is mentioned here. JSON stand for JavaScript Object Notation or HTTP's Hypertext Transfer Protocol. So this you should know. We will get into everything in detail. Right now, I'm just looking at the basics. Okay. So what user is sending through that IP address is a request. When a user sending to server using IP address is called a request. Mostly it is an HTTP request. And just for an example, I mentioned here that I want to get an user with an ID of 12. Okay, this request will be sent to web server, and web server will do what? It will get that data from database. It will first line, you can see it's ID 12, and it will provide you all other information. Like it will read from database and it will send you that information in JSON format. So right now you can see there is a JSON format that I mentioned where looking at ID number 12, we are getting first name and last name, and as well as the address of user. So, and this will be responded back to user and user can see it. Okay. So far, I have explained some process, and this model is called client server model because client is directly communicating with server and server is responding to the client request. Okay. Is there anything you need to have further clarification on this? Any doubt? No? Okay. So with this particular model, do you think there are problems which need to be addressed?
So one
No?
thing I was wondering
Hmm.
that, like the DNS, you're saying that the address keeps on changing, but for a particular area,
Mhm,
so all the people will be using the nearest one. How is it going to like either they're going to look for the distance to
mhm.
improve the latency, or they have to add more servers to get to cater those amount of people there. So how do they address this
Exactly.
problem?
See, that is one problem where auto scaling comes into picture. Depend on the user. These servers, no, this is not one server. And this is the exact point that I was about to mention that not one server will handle all the requests. Maybe millions of users are making use of this particular website. So there are chances that we have thousands or maybe millions of web servers running behind, which are taking care of all the requests. And the algorithm to have those web server register with DNS, there is a different architecture behind it, and there are different components, and we will get into it for sure. But it has been addressed. Like when there are multiple users or thousands or millions of users need to serve, then there is a different kind of architecture that we need to follow. But this is a good question, and we will look into it for sure. So I hope if there are no questions, let me quickly move to next slide or next diagram that I prepare. Yeah. The first problem with our previous architecture was everything was in web server, right? And what if the web server goes down? It was a single web server, as I mentioned. And when you're sending requests, you're putting your data related to user, whatever it is, everything within a web server. And it is possible that this particular web server may go down. Then the client will not able to access anything, whether it is data, whether it is application logic, client will not able to access it. So this will be a web server will be a single point of failure because it's a single server, as I mentioned. So how we can first tackle the problem of how to preserve data because data is more important, right? And how I can preserve that data. So and how can I get more quicker response? Because see, every all responsibility was over web server. And if web server goes down, data also will go down. And then again, you have to restore the data. Maybe you have to use some kind of mechanism through which you can restore that data. And second thing is the response that you get it. Like web server has to do an additional task apart from application logic is look at the database. Like it has to process even the database request also within the web server itself and then send you that. But that will again take out some of the memory of web server itself. And the response you may get, it will be a faster response, but it is always better to separate uh, the concerns that if data is there, why can't we store the data in a separate machine itself, which we'll call as a database. See, database is again a server itself on which the database application is stored or installed. So this is I'm just going through simple concept here. As we will go through different scenarios, we'll solve different problems. Web server is a problem because it's a single point of failure. Similarly, the database also a concern because your data is stored on that server and even data also we can loss if server goes down. So problem that we are solving, we are just separating our data from the web server. So what is happening? Same thing. You are using www.myweb.com. It has a client, mobile client or browser. It will go to DNS. DNS will send you the IP address. With that IP address, your client will send request to your web server, and web server will respond to it. But the additional step that we are doing, we have introduced a separate machine or separate server on which your database is running. So whenever we get a request that we need to read something, we need to write something, we need to update something on server, so the web server will send that request to database, and database will give a proper response. In the sense, if the we have to write the information or we have to update the information, that yes, the data has been written to the server. Am I visible?
Yes.
Yes, yes.
Okay. All right. So, and if we have to read the data, the database will return that data to web server first, and then web server will send back that data to your client. Okay. Now the question is, see, we were getting into more details of database in later stage. But at this point, I'm just giving a quick overview of what kind of database do we need. Maybe it is not relevant at this stage, but I'm just giving a quick understanding of what kind of database that we need. See, there are multiple types of database. One is relational database, one is non-relational database. Mainly what we are using, I think we have recently used SQL database or SQL database, is actually come under category called relational database management system. It is RDBMS, you might have heard of. So that's a SQL database where data is stored in tables and rows. Okay, and there are multiple similar database. Like what we use is SQL Server database, but there are MySQL or MySQL, Oracle, PostgreSQL. So these are different relational database, and usually they are storing the information in tables and rows. Okay, and mostly we do join operation. Like we create two different tables. Maybe one is user, another is employer, and then we can join them on user ID or employer ID or something. So that kind of join operation we do across multiple tables. Like we create n number of tables for data, and that join operation we usually do it in a relational database. So just emphasizing, this is a relational database management system or SQL database, and data stored in tables and rows. We'll get into more details later. There are other type of database called non-relational database, which is also called NoSQL databases. So maybe you might have heard of some of the database name like Amazon DynamoDB, HBase, Cassandra, Neo4j, CouchDB. See, these are different types of database which are depend on what kind of category that data category that you're handling. For example, key value store. There's a key, there's a value associated with it. So such kind of data can be stored in CouchDB because it's a key value store. Graph store, when there is a relationship, like one, if you look at Facebook, if I have a friend to whom there's another friend, then that friend has another friend. So this is a kind of relational database. Like one user is connected to another, another is connected to another 10 different users. So it's kind of relation between users. So it actually represented by a graph, and that's why sometimes we need graph store. Cassandra is a column store where the column itself is a wide column store where you can put in data, and there is something called document store. DynamoDB is again a NoSQL database, and here you cannot perform the join operation because most of the NoSQL database they don't support the join operation in this the way they are structured. But we'll get into these in details later on, like what exactly how they exactly look like. So we need to look at it. But I've just mentioned few points that if you have to choose a non-relational NoSQL database over relational database, what are the criterias are there? For example, if you need a super latency, in the sense you want a faster response from your database, you can use NoSQL database. You have unstructured data. Unstructured means you cannot put the data in table format, table rows and column format. So in that case, there are chances that there are no relation between the data itself. So in that sense, we can make use of NoSQL data. If you want to do serialize and deserialization of data, you can make use of NoSQL. And the data is itself is of massive amount. and you need a lot of quicker response. You want to send a query or read, write, and update, and you should get a quicker response. That time you make use of NoSQL databases. So I'm just giving a quick idea about what exactly the relational, non-relational database, what are the different categories under it, and when we make choice of data. Sim, always since last 40 years, if you ask me, I never heard of NoSQL database. But mostly we used to see, okay, there is a SQL Server database. You just put your data, and there are more advantage and disadvantage. Both are there, but we will look at it later on. At least at this point of time, this is I'm just trying to give you an overview of what exactly database, and in our system, we are just separating a layer from web server to a data layer. Like a web layer is there, or we can say web tier is there, and we are separating a data tier, and we are making a different choice of data. That what kind of this data sheet database should be. All right. So, any question on this? Any doubt? Any clarity? Further clarity? Okay. So what I'll do, I'll stop here now because this is exactly 30 minutes, and